Hey, 6th grade, it is Mr. Connolly here, and for today's assignment, we're going to change things up a little bit. I took a look at your survey questions, and one of the responses, well, not one, but a lot of your responses that I got in which I asked you, how can I make distance learning a little bit more engaging, or how can I make it more enjoyable for you? A lot of you, not even in 6th grade, in 7th and 8th grade too, as a middle school, as a whole, you guys told me, I'm not throwing anyone's name out there, but a majority of the answers said something like, make it more engaging, maybe some hands-on virtual labs. So I'm going to attempt that today, and I really hope you don't have to view this video. This video is literally just a safety net in case one of you or some of you, your computers at home don't accept the program to open up the virtual lab. And if it doesn't, what I'm going to do is I'm literally just going to project the virtual lab up onto my computer screen. And then there's going to be sections where I tell you to pause the computer screen. And then you can kind of look at what I'm doing and you can answer the questions based on, what you're seeing on my screen if it doesn't open up. But for the most part, it's a basic program. And some of you even have some Chromebooks. So if you have a Chromebook, or I don't even have a Chromebook, I don't even know what I have. What is this? Intel? I don't know what this is. But it's some computer I've had for many years since college, so it's definitely outdated, and it definitely opens up the program. So odds are you definitely can too. But if not, this video is for you to observe so you can answer some of the questions and not feel, left out that it doesn't work for you. So what you're going to see on Google Classroom in the morning is you're going to see this Properties of Waves virtual lab. So what you're going to do first is go to Google Classroom, which you do every single day, and you're going to click on the link for Wave on a String. You can use this flash link, I don't know what it's called, when you can click on it, a hyperlink, that's it. You can click on the hyperlink and it should bring you to the simulation on PhET. If it doesn't, I'm just going to copy and paste the URL below on the post for tomorrow morning, and you're going to be able to access the virtual lab simulation that way. And what you're going to do, so once you go on, here's the 2 bullet points, the 2 starting directions. So once you go on and you find the wavelength on a string, all right, if it's not working for you still, all you have to do is go to PHET simulations on Google, all right? You're going to go to simulations, you're going to click on physics, and you're going to scroll all the way down until you find the simulation called wave on a string. Okay, you're going to click on the big arrow to run it. It should look just like this. So as soon as you open up, look at the bullet point 2. It says in the top left box, choose oscillate. In the top right box, choose no end. In the box on the bottom, change damping to none. So I'm going to do the same exact thing. I'm going to go top left box, oscillate. I'm going to go top right box, no end. You'll see it going out of a window. And then for damping, I'm going to put none. All right, and I'm going to put in slow motion because it's a lot easier for me to observe and kind of like, gather my observations if it's a little bit slower than this. Okay, so here's the amplitude. Here's the frequency. You can play with this. All right, get a little sense of what's happening on the simulation. You can pause it so you can get a better look at the wave. All right, so I'm going to pause it. All right, and we're going to go to question 1. So you're going to follow the lab procedures below and steps to help answer the following questions. Use the simulation to also fill in the data for wavelength. So what you're pretty much going to be observing is we've been talking about the properties of waves. We've been talking about wavelength. We've been talking about frequency, the wave speed. And we've also been talking about wave amplitude. All right, so this simulation is literally just a way to kind of observe those 4 different features and properties of waves just to get a better understanding. That way, we don't just go over it for a day or two and say, okay, any questions? No, moving on. So for number 1, you're going to look at the wave, and you're going to ask yourself, and you're going to answer right below in the space, is this a transverse wave or a longitudinal wave? And explain how you know this. So I'm going to re-click the simulation. All right. I can put it for normal, make it a little faster. So you're going to tell me, all right, which way is the wave moving, in which direction, and which way are the particles of the medium moving in response to that direction. All right, so is this wave a transverse wave? And at this point, I think you should know what that means. Or is it a longitudinal wave? Okay, so Here's the simulation. I'm going to run it for a couple seconds. You can take a look at it. You can pause the video. You can rewind. All right, you're going to just answer the basic question number 1. Is this a longitudinal wave or is it a transverse wave? Okay? Number 2. All right, so basics. Number 2. Literally just spend a few minutes exploring the amplitude of the wave by increasing it or decreasing it. So here is me increasing amplitude. Notice how the centimeters goes up, and you'll see that the crest and trough height, right, or the maximum distance from your reference point or origin increases if I increase amplitude. And if I decrease amplitude, look how the amplitude gets much, much, much shorter, and I can even make it none. There's no wave. All right, so short amplitude, increasing, maximum distance, amplitude. Okay, so if you can access the simulation at home, maybe play around with that knob for a little bit, see what you can see what you can find. You can look at the frequency. All right, just make sure the tension is on high and the damping is on none. And make sure that there is no end up here and it's on oscillate. All right. Next one, explore how amplitude affects wavelength. So use the following settings and measure the approximate wavelength. Pause the simulation after a few waves pass and use the ruler. All right, I'm going to show you how to do that. So when you do step number 3, make sure that your amplitude is increasing every time per trial. So 0.75 to 0.90, 1.05, and 1.20. You want to make sure your frequency stays on 1.6. Okay, so frequency, I'm going to put that to 1.6 right now, and you're not going to touch that. Right? There's no reason why you should touch that. Don't touch it. All right, so first one, 0.75, 1.6, 0.75, 1.6, right? I'm going to click on the ruler tab, and you notice that I get 2 rulers. One ruler to measure amplitude. I don't need that for now. And then one ruler to measure wavelength. Remember, we can measure wavelength from 2 reference points, either from 2 troughs or from 2 crests. So what I'm going to do, I'm going to wait till 2 crests pass right here. I'm going to align my ruler at the 0 centimeter mark. I'm going to place one end at one crest, and here's my second crest. You're going to, if you cannot find the simulation, if it doesn't work, pause the video here. All right, measure the wavelength in centimeters. Okay, do that now. Great. Okay, unpause. Next thing you're going to do, set your amplitude to 0.90. Okay, so 0.90. 2 waves pass. Boom. Here's one wavelength, one crest. Here's another. Hold on. Not yet. And do it now. Now. Sorry. Right there. Pause the video. Measure the wavelength. Unpause. Awesome. Okay. Next thing. 1.05. So I'm going to find my amplitude. 1.05. I'm going to unpause it. Let another crest pass by and then pause. Here's your next wavelength. You can pause the video here. Fantastic. Okay, and then last one, amplitude 1.20. So you're going to go to the same setting you've been working with, or I've been working with, 1.20. Here goes the first crest. Here goes the second. I can pause it. And then you're going to measure the wavelength there. Pause the video if you need extra time. Great. Okay. So you're going to put in that data for the wavelength based on those amplitudes and based on the consistent generic frequency of 1.6 hertz. Moving on. So based on your data from step 3, step 4, when amplitude increases, as we increase the amplitude after each trial or procedure, what happened to the wavelength? Did it A, increase? Did it B, decrease? Or C, stay the same? Just highlight. I know you can't circle. Highlight, or you can insert a shape and maybe circle A, B, or C. But you can just highlight, or even on this line, if you just want to type in A, B, or C, fine with me too. Number 5, when a wave's amplitude increases, right, what happens to the energy? Is energy increasing? Is energy decreasing, or is energy staying the same? Remember we talked about in the past video, amplitude is directly measured or directly related to energy. So as amplitude increases, what do you think is happening to the amplitude or that hill or that crest height or that trough height? All right. 6. Return the amplitude to 0.75. I'm going to go back. I'm going to return this to 0.75 because that's exactly what the directions say to do. All right. Then spend a few minutes exploring the frequency of the wave by increasing or decreasing the frequency. So I'm going to hit play. If I increase frequency, you'll get more waves per second because that's what frequency is a measure of, the amount of cycles, the amount of waves per second or a given amount of time. And if I decrease frequency, we get less waves per second. Okay? So increasing, more waves, or more cycles of waves. Decreasing, we get less. Okay? So, same thing. Amplitude now stays at 0.75. So let's make this at 0.75. And then for each trial, 1.40, 1.80, 2.10, 2.40. So for the first one, 1.40. Let's try that out. 1.40. All right, we're measuring wavelength again. So there's 1, 2. So at this point, I need you to, well, I can get a better one than that. Right there. I need you to pause the video, and I need you to measure the wavelength of this crest to this crest, or the wavelength. Right? Unpause. Very good. Second one, 1.8. Let's make this 1.8 right there. All right, let 2 waves pass by. So here's the first one. Here's the second one. Pause the video here and measure that wavelength. Great. All right, next one, 2.10. So let's make this frequency 2.10 or 10. Here comes the first one. Here comes the second one. So at this point right now, you can measure the wavelength using the rule at the top in centimeters. Super. And then next one, 2.40. So I'm going to make this frequency 2.40. Let 2 waves pass by. Stop. And just like you've been doing, here's a plot twist. You're going to do the same exact thing. You're going to measure the wavelength using this rule at the top from this crest to this crest. All right? You can unpause. Or, if I want to play it again, you can do the same thing with the trough. So it's the same exact thing. All right? So wavelength is from 2 crests or from 2 troughs. All right? Next question. 8. When frequency increases, the wavelength does what? So as we increase the frequency, the more waves per second, or within a generic amount of time, did the wavelength increase based on your data up here? Did it decrease based on your data up here? Or did it stay the same and stay consistent throughout each trial? And then number 9, return the frequency to 1.50 hertz. All right, 1.50. I'm going to let this phase out until it's 1.50. You're going to answer the question. And the amplitude to 0.75. 0.75. We're good. All right, so let's see what the question says. Now focus your eyes on the bead of the string. In slow motion may help. Describe the motion of the string. So notice how this green bead here, this green bead here, this one, this one, this one, this one, are they moving left to right, or are they just moving up and down? So does the medium of a wave travel along the wave, or is it just vibrating back and forth? So all I need you to do is look at the individual beads. I think the green ones are probably easiest to look at, and just describe what they're doing. Are they moving like a wave? Are they moving up and down? Are they moving left to right? So how do waves travel? All right, that's the misconception with when we talk about waves and mediums, is that The wave looks like it's traveling as a whole, but the medium is just vibrating. So tell me what you see. All right, I hope this video helped, and if you have any questions,